Okay, so question. Carvone is a principal component of caraway and dill seed and is used as a food flavoring agent. Calculate the molality of a solution that contains 1.73 grams carvone and 18.5 milliliters of ethanol. And the density is given 0.7893 grams per mil. Assume that carvone is non-volatile at the normal boiling point of ethanol and that it is a non-electrolyte. So first, let's write down everything we know in this question, just because it will help us later on when we do calculations. So for carvone, we know that the mass is 1.73 grams. And let's also calculate the molar mass of carvone. So it's C10H14O. And to find its molar mass, it's just going to be 10 times the molar mass of carbon plus 14 times the molar mass of water plus the molar mass of oxygen. So these values are just found on your periodic table. Carbon's molar mass is 12.1 or 12.01. Hydrogen's molar mass is 1.01 and oxygen's is around 16. So we get a final molar mass of 150 grams per mole. Okay, so that's everything given for carvone. And on this side, I'm just going to write down everything given for our ethanol. We know that the volume of ethanol is 18.5 milliliters. And we're also given the density of ethanol as well, 0.7893 grams per milliliter. Okay, so let's use a different color and start answering the question. Step 1 is to find the number of moles of carvone. So since we have both mass and molar mass, we can use the equation number of moles is equal to mass divided by molar mass. So our mass is 1.73 grams and the molar mass is 150 grams per mole. This gives us a number of moles of around 0.0115 moles. So step 2 is to find the mass of our solvent. Mass of solvent. So let's recall that density is equal to mass over volume. So if we rearrange this equation, we can solve for mass by multiplying the density, which is 0.7893 grams per milliliter, by the volume, 18.5 milliliters. And notice that our units for mils will cancel out, and this gives us the mass of our solvent, which is around 14.6 grams. And another step here is to convert this to kilograms, because molality is equal to the number of moles divided by the kilograms of solvent. So we just convert to kilograms by dividing this value by 1,000, because 1 kilogram is equal to 1,000 grams, So now grams will cancel out, and our kilograms is 0.0146 kilograms. And now we have everything we need to find the molality of this solution. So again, molality is just equal to the number of moles divided by the kilograms of solvent. And we have both of these. Number of moles was 0.0115 for our solute, which was Carvone. And the mass of the solvent is 0.0146 kilograms. So now our molality is 0.788 moles per kilogram. Okay, so the junior tutor said that Carvone is found naturally in essential oils, but is most abundant in the oils from the seeds of caraway. In this problem, the given quantities are the following. So they also wrote everything down, and they're asked to calculate molality of the solution. So this is the number of moles of solute per kilogram of solvent. And first they found the number of moles of Carvone. They calculated the molar mass of Carvone and also got 150. And then they calculated the number of moles in the same way and got 0.0115 moles. For the mass of the solvent, they multiplied density and volume, got 14.6 grams, and then converted it to kilograms. And then finally, to find the molality, he divided number of moles with the kilograms of solvent, and they also got around 0.79. So this solution is correct.